everyone, my name is Vaidehi, and I'm really excited to be here speaking at Codeland Distributed. A little bit about me: I'm a senior software engineer at Dev, and when I'm not working at Dev, I tend to fill my free time, whatever free time I have, with side projects. I really enjoy side projects because I love learning new things. I really like getting deep into a topic. And recently, the thing I've been learning about is how we store data. This is a question I've been trying to answer because until recently, I never even thought about it. As it turns out, everything we create and share on the internet is stored somewhere. However, most of us don't really think about how and where this data is stored. As developers, we work with code all day, and sometimes we think that the data that we're working with is ephemeral. But the reality is that there are physical things that power our world. So let's try to learn more about the physical aspects of our work together. The majority of all data in computing is stored in something called a data center. A data center is one or many buildings that store servers and all of the hardware that's associated with them. Before data centers were really ubiquitous, we had to store our servers on our own, and sometimes they just all lived in a room. Veterans of the industry will tell you all these stories about server rooms because that's what people had to do. But over time, people found that data centers were easier to use than maintaining their own server rooms, and data centers became much more common. And if you use a cloud provider, then you're actually using the data center that your cloud provider provides. Cloud providers are companies that rent out servers in their data centers to everyone else. Storing your content in a cloud provider's data center turns out to be much more efficient than running a data center of your own. You don't have to maintain those machines. You don't have to worry about your own network, and you actually get access to better hardware and improved security infrastructure, like backups and distributed databases. So when you sign up with a cloud provider, one of the things that they will actually promise you is little to no downtime. In other words, they basically say that they're going to keep things running for you. But what do these providers actually have to do in order to ensure operability and no downtime? Well, in order to make sure that you can always access your data, and in order to keep their systems reliable, they often have more than one instance of a server in different locations. This is a technique called redundancy. The trouble is, the more servers you have, the more servers you need to power, and the more servers you need to maintain. And servers are demanding. A server requires energy to be powered, which comes in the form of electricity. But servers also use a lot of energy and then also emit it in the form of heat. If a server emits too much heat, it will overheat and fail. So not only do we need energy to power the server, now we need to worry about cooling it too and keeping it from overheating. And because of these hardware constraints, every data center usually has a mechanism to remove the hot air that's generated by a server and supply cool air to help keep it at a steady temperature and keep it from overheating. So really, not only do we need energy to power these servers, we now have to think about the energy to cool them too. And just how much energy are we talking about? Well, by conservative estimates, data centers worldwide use approximately 200 terawatt hours a year. 1 terawatt hour is equivalent to 1 trillion watts of energy consumed in 1 hour, which is a lot. Just for some perspective, Scotland has a population of 5 million, and the entire country only requires 25 terawatt hours of electrical energy each year. Overall, data centers currently demand somewhere between 1 and 3% of the world's global electricity. If data centers are using so much of the global electricity supply, it's worth asking, where does that energy come from? Well, the electricity to power data centers will just come from the local power grid. But the kicker is that, unfortunately, a lot of data centers rely on power grids that use fossil fuels as their main power source. Fossil fuels emit greenhouse gases into the atmosphere, and they contribute to climate change. Data suggests that the IT and communication technology industry itself accounts for approximately 2% of all greenhouse gas emissions. Now, out of this 2%, conservative estimates suggest that just the data centers are responsible for at least 0.3% of that. So another way of thinking about this number is that the tech industry and the tech sector has a carbon footprint that is equivalent to the airline industry. So what are cloud providers doing about this? A lot of it really depends on the provider itself and their values. There's a great white paper that was published last year called The State of Data Center Energy Use in 2018. And it was written by two folks in the industry who've really studied this topic so much more than I have. Their names are Paul Johnston and Ann Curry. This paper goes into a lot of detail about the environmental impacts of 6 of the biggest cloud providers. And it actually gives each of these providers a grade in terms of the sustainability of their servers and data centers. I'm only going to talk about 2 of these providers today, but I really encourage you to check out the entire white paper because it has some wonderful resources. We'll start with AWS, which is currently the largest cloud provider. So they have a commitment to be 100% renewable by 2030. AWS allows you to store your server instances in different zones across the globe. If you've ever worked with AWS, then you know that they actually have 25 different zones. But of those 25, only 5 of them are actually carbon neutral. If you store your data in a carbon neutral zone, AWS will purchase something called a carbon offset. Now, when AWS buys an offset, what they're really doing is purchasing renewable energy and putting it back into the electrical grid. These offsets are what make these zones carbon neutral. But it's really important to note that even though this sounds really good, the reality is that if you store your data in one of these zones, you're still actually emitting greenhouse gases. You're just slowing down the emissions by buying more renewable power generation from elsewhere. But those greenhouse gases are still being emitted. So it's important to note also that offsets are not a long-term solution here because they don't remove the carbon emissions from the atmosphere, they're just slowing it down. Even though AWS offers 5 carbon neutral regions, it also has regions like US East 1 in Northern Virginia in the United States. You might have actually heard of this region because a lot of companies host their data here. And whenever there are large outages, a lot of it points back to an outage in US East 1. Unfortunately, Dominion Energy, which is the power supplier for this region, has doubled down on fossil fuels. As a result, that means that every single data center in this state is contributing to carbon emissions because the power supplier is the one that's deciding what kind of energy source is used to power the local electrical grid. It's not great. And remember that goal that AWS had about being 100% renewable? Well, despite this goal, they are also continuing to open new data centers in this specific region. In fact, since 2017, they've increased their operations in US East 1 by 59%. On top of all of that, AWS isn't very transparent about public data or reporting their current energy use. They're also not really clear when it comes to sharing how quickly their energy use is growing. And all of this makes it very hard to know if the renewable energy that they're buying through those carbon offsets is actually anywhere close to offsetting how much energy they actually use. Now, if we take a look at Google, things get a bit brighter. The Google Cloud Platform buys carbon offsets for all of its servers, not just specific ones in certain regions. In fact, their parent company, Alphabet, is the largest corporate buyer of renewable energy. Compared to AWS, Google has actually been pretty transparent about the fact that they know they can't power 100% of their servers through entirely renewable energy. So instead, they've adopted a different strategy. For each kilowatt hour of energy that Google Cloud Platform servers consume, Google will purchase a matching kilowatt hour of clean, renewable energy and add it back to the power grid. So even though hosting on Google Cloud causes new carbon emissions, 100% of those emissions is offset. And it turns out Google is actually the leader in this sector, and they're really doing much better than most other cloud providers. The only other provider that has actually met its 100% sustainability goal is Microsoft, which you can read more about in that white paper. Now that we know the reality of how these cloud providers are actually powering the data centers that house all of our content, the question is, how will this energy usage of data centers scale into the future? Multiple research papers have found that global data traffic is actually growing quite quickly. And this means that as the traffic grows, the usage of data centers is going to grow to scale to meet that demand as well. Over time, this is all just going to demand more energy. This graph shows you the expected case projection of how the IT industry is going to grow over time. The estimate is that our industry, the IT and technology industry, is going to use somewhere between 8 to 21% of the total global electricity demand by the end of this decade. And given that we're an industry that cares so much about things like efficiency and scalability, I really think that we need to start seriously thinking about this problem. The question of how this is going to scale is one that we really shouldn't ignore. I have some good news though. Some of us are thinking about this. In fact, people have started solving for this problem. Some companies are building new data centers in colder climates so that it doesn't take so much energy to cool their servers. Other companies are recovering and recycling wasted heat that is emitted from their servers and reclaiming it and using it in sustainable ways. And then there are companies like Stripe and Basecamp, which don't even have data centers of their own, but have dedicated themselves to becoming fully carbon neutral or carbon negative. But it's not just cloud providers and companies that are making changes. In fact, each of us has agency in solving this problem too. The first thing we can do is find out where our data lives. We can find out whether it is stored in a region that is green and carbon neutral and powered by renewable energy. Or maybe we'll realize that, in fact, our data is contributing to the planet's greenhouse gas emissions. There's a great website called the Green Web Foundation, which helps you answer this question when it comes to your own projects, as well as the apps that you might use every day. Another thing we can do is migrate to a green region with our data if it lives somewhere that is contributing to emissions. If our data doesn't live in a green region, we can figure out what it would take to move it to somewhere that is carbon neutral. And if you're in the lucky position to start fresh and you're provisioning new servers or databases, you can choose a clean cloud provider from the get-go. Another great step that you can take is to draw attention to this issue. and talk about it with your team. If you're at a small company, this might just mean having a conversation about your cloud provider choices internally. But if you work at a bigger company, especially one that has a large enterprise account with one of these providers, you can pressure the provider to release data and to be more transparent about where their energy comes from when it comes to powering their data centers. And if you work at a company that provides cloud services, and if you have the power and the privilege to do so, you can do even more. There are some really active employees at Amazon that are doing exactly this. You can even build something to make it easy for people to find information about this topic. In my own research to try to answer this question of how we store our data, I found that it's really hard to find clear data and you have to really dig for it. And it's so important to make this data accessible to everyone in the industry. A great example of a tool to help make this data more transparent is the Cloud Sustainability Console, which is a Chrome extension. It's really simple, but it's super useful. This browser extension will highlight which regions in AWS are carbon neutral. So when you log on to the AWS console, it's very clear to you whether you're choosing something that is carbon neutral or not. But if you take nothing else away from this talk, I hope the one thing that you'll do is be aware. We should all be aware of the physical impacts of what we do every day, even though we can't always see them. And it's important for us to be aware that our industry is making an impact on all of us and the planet. Our industry relies on a finite resource, even if we can't see it or think about it all the time. And it's our responsibility to take the first step and learn about this stuff. And as I've learned more about how we store data, I've also realized that most of us just don't know what this is going to cost us down the road. We don't yet know what the cost of data is going to be to us or to our planet. And yet, despite this, I don't feel entirely disheartened. It might seem like, as an industry, all we're doing is contributing to this problem, but there's another way to look at it too. We could be the ones who start to change it. Historically, the field of technology has pushed the needle forward. And I'm optimistic that we can do it here again too. Maybe we could even start to set an example for other industries that are also tied to fossil fuels. We're a unique group because we aren't just consumers of technology, we're also the creators of it. Each of us has the power to influence and guide the industry in small and sometimes big ways. And personally, I'm really hopeful that together we can guide it in the right direction. If you'd like to learn more about the things I've been talking about and look up some of the stats, you can check out costofdata.dev. Thank you so much for listening, and I hope you found this helpful.